what I was telling is now only started the recording. So lot of students can't do this inorganic essay question within 30 minutes because of this calculation part in the inorganic question. So most of the students, like people who are below 60 marks, 70 marks, they tend to do the industrial question by leaving the inorganic question. But actually that is a good thing to do. Actually, if you are like below 60 or 50 something, then you have to go for the industrial question. Industrial and environmental, sorry, industrial and may organic question only you have to go. But in case if you're good with inorganic and you just mess up this calculation part, you no need to go for the industrial question. You can just do the inorganic question. You can check 2024 paper, just a flow chart. Hari, just kata analysis is there in part 1. In part B only you have the calculation part, a little bit different question you had in 2024. So however, the normal question pattern for the calculation part is given on the left hand side. Normally, like this is the way they are going to ask question. This is a little bit tough question. Like past papers, you can see they are much easier. So approaching this question is like you should act like Sherlock Holmes here, and you should have a clear mind in order to do this question. That means you should know what you're doing. It's like driving a vehicle, people driving a vehicle in a traffic, right? Driving a manual vehicle, not auto, like driving a manual vehicle in a traffic. That's so hard, right? You have to push the clutch and then like, lift the clutch, then press the accelerator at the right amount, and then apply the brakes, and like you cannot stop the vehicle in behind. And if it's a hill, then it's going to be even more hard. You have to be very careful, and you should have high amount of focus if you're going to drive a manual car in a traffic. So doing the calculations essay question is also like that. You should have a clear mind in order to do this question. Okay, so what are the steps to do this question? First of all, they will ask you to write the reaction. So of course you have to write the reactions. Reactions ටික ඉස්සෙල්ලා ලියා ගන්න. හරිද? Reactions ටික ලියාගෙන have a diagram. That means you should look at this. දැකලා තියෙන movies වල, in movies they are going to like put a regiform board in front of their like එක එක pin කරන්න, like there's a photo here, there's a photo here, then they will match this and they'll say there's a connection. Now this is the murderer, right? This is the murderer and this is the victim. So they are connected with each other, and there is a brother of the victim, and that brother is connected to the murderer. Likewise, there is going to be an investigation going behind such murder cases you have seen in movies and stuff, something like this. So in calculations essay question also, you should do the same thing. You should analyze this question by looking it from the top, like what is happening, like first of all you should know inorganic. You should know inorganic. You should know how to balance redox. The redox balance can have it. No, you should know how to balance redox, and then you should have the ability to look on top of the question and have an idea on what's going on here. So that's the first thing you need to have. That's actually the main thing you should have. If you have that, then this question pattern is not going to be very hard for you. So a lot of you are messed up here, how to do this, like what is the procedure, I don't know. Like sometimes I get wrong answers, sometimes I get negative answers, sometimes I get impossible answers, and then it's a mess. Like I can't even track. I can't go back and track where did I did my mistake. Like I'm getting like invalid percentages, something like that. A lot of students are complaining. So let's look at this question now. Guess essay question number 1. Let's read this question carefully and let's draw a diagram for this first of all. Let's understand what's happening here. Now, a metal ore consists of copper 2 sulfide and iron 2 sulfide. Okay, there is a sample. There is some sample somewhere. It contains, there is some sample. I'll say this one. This is a sample, can't see neither. I'll say red color. I'll draw in red color. This one. There is a sample here. Now this sample contains what? This sample contains copper 2 sulfide. Again, copper sulfide. This one, copper 2 plus iron, contains the copper 2 plus iron and contains the sulfide ion. And it contains iron 2 sulfide, FeS. So it contains Fe3 plus and S2 minus as the chemical components of the commercial importance. Now, there are other inert materials also. They haven't mentioned anything, but there are inert materials here. Then, Now, in order to find the percentage of copper, iron, and sulfur, we are going to calculate the percentage of copper. We are going to calculate the percentage of copper, sulfur. This is also sulfur. Like sulfur means everything. Like copper sulfide also contains sulfur. FeS also contains sulfur. So everything we have to calculate. And Fe3 plus also we have to calculate. Fe3 plus the amount of Fe2 plus. Fe2 plus amount of Fe in the solution. In the O, we have to calculate percentage actually. Okay, let's read further. In order to find the percentage of copper, iron, and sulfur by mass in the ore, the following experimental procedure was done. Now only we are moving into the procedure. Now this type of thing is called analytical chemistry. Now when you go to university and all, you learn more deep into this. We are going to do more procedures into this. And then like calculating percentages, calculating ppm values, like analyzing a water sample in a river and calculating how much of like dissolved oxygen is there. Something like that. This is called analytical chemistry. We are doing different reactions in order to calculate percentage of different substances. So let's see. So if there are toxic materials and all, we can just analyze this using chemistry. So this is called analytical chemistry. So let's see. 1 gram of sample. Let's draw this, okay? 1 gram of sample. Stay with me, stay here. You have to have your focus right on the screen, okay? Should have your focus here. Don't let your focus go away. There is 1 gram of sample. Okay, there's 1 gram of sample. Again, sample of this. Only 1 gram of sample. It contains what FeS and copper sulfide. Was heated with concentrated nitric acid. Now we are adding concentrated nitric acid, HNO3. What will happen is every iron in the solution will get oxidized. Actually, they have told what will oxidize. They are adding HNO3 and dissolving this 1 gram sample in HNO3. You can imagine this procedure. Right. Then, if you lost track on this, you will feel a mess. Make a hurry at a track track like be in the class. Don't even look side for like 1 second. You will miss a lot. Everything I say is important. So please give your 100% focus to this. After I explain how to do this question, you can try all the past papers under this topic and you will feel much more better by analyzing those questions. I mean, like when you do for 1, 2, 3, 4, 5 questions, 6th one will be easier than the 5th one. 5th one will be easier than the 4th one. 4th one will be easier than the 3rd one. Likewise, you have to move forward. So let's see, 1 gram of sample reacting with HNO3, may sulfate ions sulfide ions are oxidized to sulfate ions. So what will happen is sulfide ions in this solution, methane, this sulfide and this sulfide, those people will oxidize to sulfate. Obvious. The F2 minus will go to sulfate. So that is oxidation. And then we oxidize to Fe2 plus ions oxidize to Fe3 plus ions. Perfect. Fe2 plus ions oxidize to Fe3 plus ions. Nice. Right. Now what? The resulting solution was filtered to remove rocky impurities. Make a solution rocks and all, sand and all. We are going to remove those particles and we are going to make a pure solution. Pure solution, and this is called solution S. Toddy solution. It's a big solution, people. We have a volume of 250 cubic centimeters and this is called solution S. Now what does it contain? This contains sulfate. This contains sulfate formed by this sulfide after adding HNO3. It contains Fe3 plus formed by oxidation of Fe2 plus. So Fe3 plus is there. Fe3 plus is there, and initially there is copper, right? Copper, nothing was happened by adding HNO3 in it. So copper 2 plus is also there. Now this is called solution S. There is sulfate, there's Fe3 plus, there's copper 2 plus. Now here there's a reaction going on. You have to track that reaction. I'll write the two reactions here itself so we can have a clear idea on what's going on. So I'll write the reaction between sulfide and HNO3, so minus, NO3 minus, nitrate ion will reduce to NO2. Meanwhile, sulfide will go to sulfate. Now, this reaction is similar to that reaction I taught you in inorganic under HNO3. I told you there is a reaction in between H2S and HNO3. This reaction, something like this, Hari. Make after like heating the solution, you react with sulfide and then you get H2SO4, that reaction. Hari? The same reaction may don't, if you can't remember that, just forget it. Hari? If you can't remember that, just forget it. Just focus on this. Just forget it. Can I revise that later? Hari? For now, just forget it. Hari. NO3 minus goes to NO2 and sulfide ion will oxidize to SO4 2 minus. Now here minus 2, here plus 6, here plus 4, here plus 5. So that means 6 minus minus 2 is 8, 4 minus 5 is 1. So here 8, here 8. Now you have to balance the H plus, right? So H plus, now this is acidic, HNO3 is acidic. So here minus 8, minus 10. Charge on left hand side minus 10, charge on right hand side minus 2. So you have to add 8H plus to the left hand side, 8H plus to the left hand side, and 4H2O to the right hand side. Now after you put water, by balancing the hydrogen, just make sure that your reaction is correct by balancing oxygen also. Just check whether oxygen is balanced. 18 to 2, 16 on the right hand side, 16 and 4, 20, 20 and 4, 24. This side 18 to 24. So oxygen also balanced, everyone is happy. Then we can move on to the next reaction. So this is the oxidation of sulfide ions to sulfate by HNO3. Perfect. Now what? Now, දැන් මේ සල්ෆයිඩ් ඔක්කොම හරියද? now FeS and මේ copper sulfide කියලා දෙකක් තිබ්බනේ. දැන් FeS and CuS ඕකේ තියෙන ඔක්කොම sulfide ටික, both copper sulfide and iron sulfide, everything is sulfide now because it is like dissolved in the solution. Everything is sulfide. Hari. Now what is the other reaction? Fe2 plus and NO3 minus, Fe2 plus and NO3 minus. NO3 minus will go to NO2 minus, and Fe2 plus will go to Fe3 plus. Nice. Now, here, NO2 minus, sorry, this is NO2. This is NO2. Right. So NO2 is plus 4 oxidation state. This one is plus 5 oxidation state. This one is plus 3 oxidation state. This one is plus 2 oxidation state. So I think everything is balanced now. Like we don't have to change the stoichiometry of anything. We just have to balance the charges. Charges are different, however. Right hand side total charge is plus 3. Left hand side total charge is plus 1. Plus 1. So we have to add 2H plus to the left hand side. 2H plus to the left hand side. And then right hand side, we have to add H2O. Right. Now oxygen also balanced. See 3 oxygen in the left hand side and 3 oxygen on the right hand side. Now this is the first step of the question. Identifying this and having a clear picture of what is going on. Everyone, are you okay until now? Like, are you like literally listening to this and you're okay with this until now? Did you understand until now? We just did everything until this, okay? We have finished this part of the question. We have finished this part of the question. We have finished that, right? We have finished that. Did you understand? Drop me a message. Everyone. Everyone in the session, please talk. I will point out your name if you don't talk. Talk and you can send a message. Don't need to unmute. Okay, I'll go through this part again from the beginning. I'm only doing like this only for the first question. Okay, after that I'm just going on discussing. පළවෙනි question එක විතරයි මෙහෙම discuss කරන්නේ. හරි. So people, there is an iron ore. It contains copper sulfide and it contains iron sulfide, Fe2 plus sulfide and copper 2 plus sulfide. Okay, now 1 gram of that is taken and then we are going to react it with, again, that 1 gram, just imagine you're putting it into a concentrated HNO3. There is no concentration, nothing, just HNO3. Sulfide is going to oxidize to sulfate and Fe2 plus will oxidize to Fe2 plus, Fe3 plus, sorry. And now we are writing those reactions. We are just balancing those reactions. So reaction balancing, you should have an idea. Redox, sorry. So if that reaction, sulfide and NO3 minus, that reaction, HNO3 will in NO3 minus, that NO3 minus will react with sulfide to form SO42 minus and NO2. That is inorganic. Where do we learn that? Under HNO3. And then next one, HNO3 will react with Fe2 plus. Now Fe2 plus will oxidize to Fe3 plus. Nitrate will go to NO2. Right? That reaction also will be balanced. Now this solution, we are diluting it up to 250 cubic centimeters, and now this big solution is called S. What does this S contains? It contains sulfate, it contains Fe3 plus, it contains copper 2 plus. Now go to the next question carefully. A 25 cubic centimeters. Making 25 cubic centimeters of 250 cubic centimeters. That is how much? That's like 1/10, right? Around 1/10. Around 1/10 of the big solution. So let's say like you have 10 moles here. 10 moles of copper 2 plus. You have 10 moles of copper 2 plus in 250 cubic centimeters, let's say. That means in the solution taken out, 25 cubic centimeters here, that one contains how much? Only 1 mole. It contains copper 2 plus only 1 mole. You have to understand that. That is 1/10 of the initial solution. It is 1/10 of the initial solution. Do not forget that. Okay. So copper 2 plus amount in 25 cubic centimeters will be 1 mole. Now this is not 10 moles. Okay, I just told that as a reference. Okay, that one I'll told it as a reference for you to like understand what's going on. So everything, not only copper 2 plus, Fe3 plus, copper 2 plus, sulfate, everything, like it's going to reduce by 10th. Because like 250 welling, 25 cubic centimeters you're taking out. It's like a sugar bottle at home, people. You're just taking 1 spoon out of it. You're just taking 1 spoon out of it. You don't take everything out. Okay, 25 cubic centimeters you take out. Now, portion S was measured. Acidified with dilute nitric acid. Now, already it is acidified. They don't need to say like again acidified. It's already acidified because they said initially heated with concentrated nitric. And the concentrated nitric heat kara කියන්නේ ඕක ඉතුරු වෙනවනේ කොහොමද people remain නේ. හරි. So yeah, may acidified with dilute nitric acid and excess barium chloride solution is added. Okay, now they tell a substance X precipitated was filtered, right, weight, and the mass was found to be 0.1864. In inorganic mama katta kadenakan kiyala dena, like every day I tell this, there is a white color precipitate which doesn't dissolve in dilute acid. What's it? There is a white color precipitate that does not dissolve in dilute acid. Every year they are asking this, okay? Every year they are asking this question. Either in this calculation or like even in the inorganic essay part or structure essay part or MCQ, wherever they are going to ask this, barium sulfate. Do you remember that? Hari? So now they are adding barium chloride to the solution, okay? They are adding barium chloride to the solution. When they add barium chloride to the solution, what will happen is, now nothing will happen with Fe3 plus and copper 2 plus. So something should happen with sulfate. This sulfate will join with barium 2 plus to form barium sulfate. So that is the white color precipitate. Anna a clearance එක ඔළුවේ තියෙන්න ඕනේ. So what is the white color precipitate? And like they have given the mass also. Now the thing is simple. You know the amount of sulfate now. You know, you can find the amount of sulfate in this solution. I'll find that right now. I'm not going according to this question asking method. I'm just telling you how to crack this question. It was a කැමති order එක කරලා ලියා ගන්න බලන්න. First of all, they're asking what is X and Y. Let's write that later. Mass of X can barium sulfate. Now you can write that. X is barium sulfate and Y, we are going to look at it later. Actually, Y is going to be copper iodide. When I look at this question, I can understand that like 5% potassium iodide and a white color precipitate form. But a wedding cake theory at the inorganic color or inorganic danagan only me question you should know inorganic. Let's look at it later. Now barium chloride is added. Now barium chloride added means Let's write that reaction also. Now this reaction also you have to write, okay, in the exam. Sulfate forms barium sulfate, that's a precipitate, and then 2Cl minus, right? 2Cl minus. That guy is going to form. Now barium sulfate mass they have given. Let's calculate ne? Molar mass of barium sulfate. For this one also they are going to give marks. Molar mass of barium sulfate 244, right? As I remember. Molar mass of barium sulfate. Wait, let me check. Molar mass of barium sulfate. 233. 233. Yes, 230, 244, right? 233. 233 grams per mole. Again, make a nikan liyan adme lakunu dini. You have to just add and write. Metan add karala liyan. Just add and just get the answer. Okay, for that you will get 1 mark. 1 mark in the calculation part. Just calculating molar mass. Okay. Now, number of moles of barium sulfate. Number of moles of barium sulfate will be mass over molar mass, right? What is the mass? 0.1864 grams divided by 233 grams per mole, right? 233 grams per mole. There you go. Now, when you divide, you can see grams and grams cancel off. Grams and grams cancel off, and then per mole comes on top. So, if you calculate that, 0.1864 divided by 233. 0.0008. That's going to be 8 10 to the power minus 4. 8 10 to the power minus 4 moles. That's going to be the number of moles of barium sulfate. Yes. 8 10 to the power minus 4, you can write 0.8 10 to the power minus 4. Now, this is the amount of barium sulfate that is precipitated. So, number of moles of sulfate in solution X. Same amount, same amount, because like here stoichiometry is 1:1. Stoichiometry 1:1. Therefore, the amount of sulfate in this solution will also be how much? 8 10 to the power minus 4. 8 10 to the power minus 4. Now we know the amount of sulfate. Now what you do? You know the amount of sulfate. That means you know this one. You know that one. But I told you, people, here 250 cubic centimeters of solution is, you are going to take only 25 cubic centimeters out. Now I wrote here, number of moles of sulfate in solution S. S කියන්නේ මොකක්ද? S කියන්නේ මේ big solution. How to multiply it by 10. Do you understand? හරි මම මේක statements දෙක කරලා ලියනවා. I'll write in two statements. හරි number of moles of SO4 2 minus in 25 cubic centimeters of S. මම එහෙම ලියනවා. එතකොට හරි 8 10 to the power minus 4 moles. Now I write number of moles of SO4 2 minus in 250 cubic centimeters. That's what we need. That is solution S. That is solution S. That's going to be 8 10 to the power minus 3. Why is that? We have to multiply it by 10. Methana 25, methana 250. So 10 times that value, right? 10 times that value. 8 10 to the power minus 3 moles. Okay. Now we know the amount of sulfate. Now how do you find the amount of sulfide? Stoichiometry. Like this is like what do you call? Inorganic. Inorganic redox. The redox balancing. So sulfate amount, you know, you can just calculate the sulfide amount. 1:1. Stoichiometry 1:1. Number of moles of sulfate is to number of moles of sulfide is equal to 1:1. 1:1. Therefore, make then calculation question එක කරද්දි මම මේ කරනවා වගේ හරියට ලස්සනට ලියන්න. First of all, write the reaction and then calculate the molar mass, then separate line, and then next line number of moles of barium sulfate, and then next line we have to write number of moles of barium sulfate. Number of moles of SO4 minus in 25 cubic centimeters, then 250 cubic centimeters. Doesn't matter if it takes even more steps. Doesn't matter. Just do it correctly and nicely and with beautiful letters. Write it. You will never get a wrong answer when you do it with more clarity. Like එහෙන් කුරුටු ගන්නවා මෙහෙන් කුරුටු ගන්නවා එහෙන් simplify කරනවා. At the side of the paper you are calculating here something and then here also calculating, here also calculating, here also calculating. Just don't do that. Have a rough worksheet on the side. Hari? People, is my screen lagging? Like my voice and my screen, it's not going together or something? No, right? මට මෙහෙන් lag වෙනවා වගේ පේනවා ඒකයි. Is it lagging? No. After writing sometime only I see my board. That's it. Lag වෙනවා නේ. I can't do anything about it. Some people say no, some people say yes, little bit. So is it okay? Like it's fine, right? You can manage me? You can manage. Okay, fine. So like that everywhere, just have a nice sheet of paper for doing calculations. Hari? Okay, and paper marking people, they like nice papers. They like the people who have written nicely. They will like to mark your paper. Like mentality is important because humans are marking these papers, not robots, not machines. Machines don't mark your papers. Only humans mark your papers. So it's all about emotions, right? You have to make him like your paper. It's a mental game. There's like lot of things to learn in A levels. It's not about just writing the answers and coming home. It's about writing it nicely, writing it such that the paper marker will like your paper and like මොකක් හරි කරලා ලකුණු දෙයිනේ people. Like if you have written nicely and like it's like pleasant to him, he will give marks. අර මොකක් හරි කරලා ලකුණු එහෙම හරි මෙහෙන් හරි එකක් හරි දෙකක් හරි දෙයි. That is important. Right? That is important. So make sure you write it nicely. So number of moles of sulfide will be the same, 8 10 to the power minus 3 moles. Right. Now we can calculate the mass of sulfide. Now we can calculate the mass of sulfide. Then S එක හැදුනේ මේකෙන්නේ. S එක හැදුනේ මේකෙන්. You can see here in the question they have told. Here 1 gram was sample was heated and then like it was diluted to volume of 250. Sorry. Now we can calculate the mass of sulfide. Mass of sulfide. Again, mass of sulfur mass of sulfur 8 10 to the power minus 3 moles multiplied by 32 grams per mole. 32 grams per mole. Per mole and mole cancel off. 32 into 8. 8 into 2 16. 1 remaining. 8 into 3 24 and 25. That's going to be 0.256 grams. We have calculated the mass of sulfur in the solution now. Now this is 1/3 of the question done. 1/3 of the question done. We have calculated the mass of sulfur now. Now what you do? Mass percentage. Mass percentage of sulfur is equal to 0.256 divided by 1 multiplied by 100. That's it. Don't just panic. Just that's it. 25.6%. 1/3 of marks you have now. You have 1/3 of the mark. The inorganic part take a fully karanna. If you do it fully, like if you know inorganic so well, part B ke me bhagyak hari karala dan. Adduma dharame, like you don't have to do everything. At least this do and go. Because these marks are very like annivaring hambena. One more thing I told you when doing industrial in class, I told you inorganic question එක ලකුණු අනිවාර්යෙන් දෙනවා. Like if the answer, like you get an answer, then that is correct people. මේකේ මොකක් හරි අවුලක් තියෙන විදිහක් නැහැ. Like very less chance නේ. But in environmental and industrial, what is wrong is even if you write the answer, you might get it wrong because marking schemes are different. Like it's like bio essays. It's like bio essays. I don't like industrial essays much. I mean, like in my A levels also, I didn't write it much. I wrote only inorganic most of the time. But industrial, you have to like respect the marking scheme and write. Even ranking students, it's hard for them to score more than 130, 140. Inorganic අනිවාර්යෙන් 150. Inorganic කරොත් අනිවාර්යෙන් 150. හැබැයි industrial කරොත් 130, 125, 135. I have seen this. I have been with top rankers. I have like studied with top rankers also. Those guys get lesser for the industrial question. That's why I'm telling. So you guys can score actually. You can easily score 100 in industrial. If you want marks, if you like challenge for marks, then you have to go for the inorganic question. But my idea is get ready for both and go to the exam and then decide what you're going to do. Because sometimes the inorganic question could be hard. Sometimes you will have no idea what's there even. Like you don't understand it. But industrial question, it's easy. right? That kind of thing might happen. So you can do the industrial question. Like mama inorganic එක කරේ මන් දැක්ක question එක අමාරුයි කියලා, but still I did the inorganic question because I was so like confident with inorganic back then. Industrial question was easy, but inorganic question I did because I had so much confidence in it. So you guys, if you have confidence in industrial, then you do industrial. If you have confidence in inorganic, then do inorganic and make your mistakes and go to the exam just like this. Okay, now another procedure is going on. So this is a different story now. Okay, another 25 cubic centimeters of solution is. Then metana 25 cubic centimeters gattani. We are going to take another 25 cubic centimeters. Make a green color danna. Another 25 cubic centimeters. Okay, I'm going to put it in green color. Exam එක මෙහෙම දාන්න එපා හරියට 20ක් වගේ. I'm just putting it because in order to see. Hey, see 25 cubic centimeters. Okay, from that original solution, another 25 cubic centimeters. Now what you're going to do? You're going to react. I'll write in green color, so it's like different procedure. So another 25 cubic centimeter portion of S was acidified with dilute sulfuric. Okay, dilute sulfuric is added now. Dilute sulfuric is added, okay? And then excess potassium iodide is added. Okay, I minus is there now in the solution. Okay, I minus can do what? It can oxidize, right? I minus can oxidize to I2. Again, Nikan Tanium oxidize and he cannot oxidize alone. There should be someone who can reduce. So who is there who can reduce now? Sulfate will not reduce. Sulfate, of course, it will not reduce people. Again, in our syllabus, we don't have any reactions where sulfate is reducing. So, sulfate එකක් reduce වෙන්න you have to have good like හොඳ condition එකක් තියෙන්න ඕන එක reduce වෙන්න. සාමාන්‍යයෙන් sulfate is a very stable ion people. We don't like see often like sulfate is reducing. If that is reducing, they will say it in the question. And now Fe3 plus is there, right? Fe3 plus can reduce, right? Fe3 plus can go to Fe2 plus, possible. Copper 2 plus also can go to copper plus, possible. Hari? Have copper 2 plus reaction, this is very famous. Copper 2 plus I minus goes to copper plus and I2. People, this is the wedding cake reaction. Can you remember? The wedding cake I told you. This copper plus will react with another I minus to form copper iodide. This guy is a white color precipitate. This is a white color precipitate. It's a white color precipitate. It will form, now in the solution, if this is a solution, at the bottom it will form a white color layer. At the bottom it will form a white color precipitate. It's like a wedding cake. In the wedding cake you have white color bottom. I like the wedding cake so much, people. It's so tasty. And on the top, people, you have a brown color solution here. What is that brown color solution? That brown color solution is iodine. That brown color solution is this iodine. So this is the wedding cake observation where you see copper 2 plus reacting with I minus. Copper 2 plus will go to copper plus and then I minus will oxidize to I2. Okay. So that is a reaction that is happening now. Copper 2 plus can react as well as Fa3 plus can react. Fa3 plus also can react. I minus reacts to form I2 and Fa2 plus. Possible. Can happen. Right? No arguments. It can happen. Fe3 plus can reduce to Fe2 plus and if I minus can oxidize to I2. So we have to balance these two reactions now properly. You have to balance these two reactions properly. And then read the next part. Okay? Now I'm going to balance these two reactions. Okay, right. So copper 2 plus will react with I minus to form I2, and then now I minus will oxidize to I2. Here 2I minus, because I have told you how to balance redox equations. Please don't ask why did I put 2 there. Copper 2 plus will go to copper plus. Right? Copper 2 plus will go to copper plus. Now let's balance this reaction first. Left hand side, total charge. Left hand side, total charge. Now, before that, we have to balance the oxidation numbers. Here plus 1. Here 0, here minus 2, here plus 2. So here to here 1, here to here 2. 1 times 2. So here 2, here 2. Okay. Now charge balancing. Left hand side total charge plus 2, right hand side total charge plus 2. So there are no issues. We don't have to add H plus or anything. But we have to do something here. What is that something? Copper plus will react with I minus now. Right? Copper plus will react with I minus to form copper iodide. Copper iodide will be a white color mass. This copper plus formed will react with I minus in the solution. Solution in I minus react karala. It's going to form copper iodide. Okay, it's going to form copper iodide. That is going to be the white color precipitate. That's going to be the white color precipitate. Okay. Bushra sign a base your connection unstable. You are going and coming, going and coming, going and coming. If it's hard to stay, you can watch the recording. It's fine because joining and coming, you will waste time because you won't understand the question. So it's your choice. If it's a bad connection, then you can like watch the recording later because it's already recording and there's no connection issues here. Okay then. So yeah, copper iodide is formed. Now the other reaction Fe3 plus. People, we can write this reaction straight away. මෙතන copper iodide දාලා ලියන්නත් පුළුවන් කිසි අවුලක් නැහැ. Then you have to add the I minus to here also. හරි මේ පැත්තට I minus දාලා තමයි ලියන්න ඕනි. Fe3 plus reacts with I minus to form 2 and Fe2 plus. Here plus 3, here minus 2, here 0, here plus 2. And here to here 1, here to here 2. 1 multiplied by 2, so here 2, here 2. Left hand side 3 into 2, 6 plus 6 and plus 4. Right hand side also plus 4, only to add H plus, everything is okay. Right, now these are the two reactions. These are the two reactions. This is the reaction number 1 and this is the reaction number 2. Both are happening. Okay, both are happening. Both are happening. Now let's read the next part. Now only we move into the next part. Now see, the liberated iodine was titrated with 0.04 mole per cubic decimeter. Okay. Sodium thiosulfate solution kept in the burette using a starch as the indicator. At the end point of the burette reading was 20 cubic centimeters. Now this liberated iodine, this is important. All these iodine, okay? I mean everything, every iodine molecule that is produced from both the reactions, we can know the value of them. How are we going to know the value? Let's write, easy. Let's write number of moles of thiosulfate. Now let's write that reaction also. Ne? Thiosulfate reacting with I2, that reaction also let's write. S2O3 2 minus 2S2O3 2 minus goes to I minus. This is a very famous reaction. Every past paper has this. Hari thiosulfate reaction. S2O4 2 minus. S4O6 2 minus. Sorry. Right. Now this is the balanced chemical reaction. You know this one. How are we going to find that one? They have given the volume. Here, they have given the volume. And they have given the concentration. Sulfates, sodium thiosulfate, concentration, volume, they have given. Let's calculate that. Easy. Number of moles of S2O3 2 minus. Number of moles of S2O3 2 minus. That's going to be 0.04 mole per cubic decimeter multiplied by 20 10 to the power minus 3 cubic decimeters. Per cubic decimeter and cubic decimeter cancel off, and then it will become 0.4 multiplied by 2, then it's going to be 0.8 multiplied by 10 to the power minus 3. That's going to be the number of moles of S2O3 2 minus. Now stoichiometric ratio, 2:1. If you know sulfate, if you know thiosulfate, then you can know the value of I2. So number of moles of I2 will be half of number of moles of S2O3 2 minus. Agree? Every one of you, do you agree with it? Right? Do you agree with it? Now, half multiplied by 0.8 10 to the power minus 3. And it's going to be 0.4. Okay. Number of moles of iodine totally we have found. That means the addition of this iodine and this iodine both. Both iodine we have calculated. Okay. Now, another point they have given. See, at the end of the titration, white precipitate Y settle at the bottom of the flask and right, and weighted, the mass of the Y was found to be 0.0381. That one. Hari මොකක්ද? The mass of copper iodide. That is the white color precipitate. The mass of copper iodide. So molar mass of copper iodide. Molar mass of copper iodide. Molar mass of copper iodide will be how much? Copper is 63.5 and iodine is 127. So 127, 127 plus 63.5. 127 plus 63.5. That's going to be 190.5 grams per mole. Okay, 190.5 grams per mole. Now you can calculate the number of moles of copper iodide. Number of moles of copper iodide will be the mass 0.0381 grams divided by molar mass 190.5 grams per mole. Grams and grams cancel off, and then per mole comes on top. And then let's divide now. 0.0381 divided by 190.5. That's going to be 2 10 to the power minus 4. I'll write to 0.2 10 to the power minus 3 moles. Okay, now number of moles of copper iodide you have calculated. Right now, what you have to do is we have to trace backwards. How are we going to trace backwards? What are we doing? Trace back. How are we going to trace back? You know the amount of copper iodide now. You know the amount of copper iodide. What you do? You go back. You go back means you can calculate the amount of copper plus formed. Otherwise, there won't be any copper plus. Only copper plus can be formed from this reaction. Otherwise, there won't be any copper plus in the solution, right? So copper plus is formed from that reaction. So if you know the amount of copper iodide, then you can know the number of moles of copper plus. Right? Number of moles of copper plus. So number of moles of copper plus will be 0.2 10 to the minus 3. Same value. Same value. Same value. Same value. Now, if you know the copper plus amount, what you can do? You can calculate the copper 2 plus amount. You can calculate the copper 2 plus amount. Also, you can calculate the number of moles of iodine also. Because now we know the total amount of I2. Total amount of I2, you know. If this is, let's say 10, if this is X, and total is 20, you just calculate 20 minus 10 is X. Something like that. If we know one of them, we can calculate the other one. Because we know the total. Total I2 we know. We know the addition of this one and this one. So if we calculate this one, we should find this one. Right? If we calculate that one, then you can find this one. Just think a little bit and then you will get a hold of it. First of all, let's not talk about this I2. First of all, let's calculate the concentration of copper 2 plus now. So number of moles of copper 2 plus will be same value, 0.2 10 to the power minus 3 moles. So this number of moles of copper 2 plus in where? 25 cubic centimeters of solution S. 25 cubic centimeters of S. In 25 cubic centimeters of S only you have this concentration of copper, number of moles of copper 2 plus. Okay. Now people, now you have to go back. Now you have to go back means the solution S. Green color arrow. You can see only I took 25 cubic centimeters. That means the total will be 10 times more, right? The total will be 10 times more. The number of moles of copper 2 plus in 250 cubic centimeters of S. 250 cubic centimeters of X. S how much? 0.2 multiplied by 10 into 10 to the power minus 3 moles. Easy. 2 10 to the power minus 3 moles. Okay, 2 10 to the minus 3 moles. Now what? Now you know the number of moles of copper 2 plus. You just have to calculate the molar mass. You know the molar mass, then calculate the mass. Mass of copper. Right? It has only one copper. So copper is going to be 63.5 grams per mole multiplied by 2 10 to the power minus 3 moles. So 63.5. 63.5 multiplied by 2. 127. So 0.127 grams. There you go. You won't get negative answers. You won't get like impossible answers. You can see we get nice answers now, right? We get nice answers now. 0.127 is the mass of copper. So mass percentage of copper. Mass percentage of copper is 0.127 grams divided by 1 gram multiplied by 100. That's going to be 12.7 grams. Then මෙහෙමයි. Don't think that I am perfect. I don't think that I am like just because I'm teaching chemistry doesn't mean I am like I know everything. It's not like that. I also was there in your face, people. I also made mistakes. I also got negative answers. I didn't have any idea how to do a question like this. Hari? But that was at the beginning of A levels. Okay, I was like, okay, when going to the exam, may wage stage එක I knew how to do it. What I was talking is at the beginning, like when I was learning this for the first time, like 2023 batch එකේනේ මං හිටියේ. ඒතකොට class ආපු මුල් කාලේ around 2021 or something, and 2021 or 2 ඒ වගේ year එක මේ when the sir did in class, I had no idea at all. Believe me or not, I had no idea at all. What I did was I took the past papers and I did the past papers one by one by one by one by one. I looked at the marking scheme and I realized how they have done the question. And then only I went back with that method. And I tracked the method which my class teacher also does. Hari, iskole class teacher in class teacher class teacher oh yes. And I tracked her method also, and I looked at the tuition sir's method also. So all of that combined, I did my own thing. Like nobody just fed it to me by the spoon. Nobody fed it to me by the spoon. I just realized it on my own by taking the help of others. That's what I did. So you also have to do it the same. හරිද මම මෙතන ලස්සනට answers මෙහෙම ගත්තට you might not get like this or get negative percentages, and like you will get something like that, right? Everyone has gone through that. Right? Everyone who has like won in A levels has at least got something wrong. Like හැමෝටම වරදිනවා. හරිද? හැමෝටම වරදිනවා. Everyone will get it wrong. So don't worry about it. It's okay to get it wrong, right? It's okay to get it wrong. So 12.7%. That's going to be the mass of copper. 2/3 of the question done. Hari? 2/3 of the question done. Now people, now then අර මං කිව්වේ I2 අමතක කරන්න කියලා. I told you to forget about I2, right? We can calculate the I2 amount now. Number of moles of I2 formed from reaction. මේ ඔක්කොම ලියන්න. හරිද? In the exam, don't worry, just write it. හරිද? Then you will understand the question also. Number of moles of I2 formed from reaction between copper 2 plus and I minus. අයි තව එකක් තියෙනවනේ මේ Fe3 plus and I minus. එකක් තියෙනවනේ. මං කියන්නේ copper 2 plus and I minus. The number of moles of I2 formed from reaction between copper 2 plus and I minus. නැත්නම් ඔයාලට ලියන්න පුළුවන් number of moles of I2 formed from copper 2 plus. එහෙමත් අවුලක් නැහැ. කොහොම හරි කවන්න නැහැ ලියන්න. හරි. It might take some amount of time, but this is at the beginning ne. So you are just learning ne. Hare? You're just learning. So you can write it like this when practicing at home. So copper 2 plus I2 formed from copper 2 plus. How are we going to calculate the stoichiometry? Stoichiometry, you can see 2:1, right? We know the amount of copper 2 plus. We know the amount of copper 2 plus. So we can just write number of moles of copper 2 plus. Number of moles of copper 2 plus wage half amount. Like 2:1 ratio. So half amount multiplied by half. So that's going to be number of moles of copper 2 plus we calculated 0.2 10 to the minus 3. And do not forget people, we have to take this 25 cubic centimeters one, okay? Not the 251, okay? And එහෙම කරාම තමයි ඔය like 200% values එහෙම එන්නේ ඔන්න ඔය වගේව කරාම. හරි? You should know that we are just putting it to 25 cubic centimeters thing. හරි? මේ analysis එක වෙන්නේ 25 වලනේ. And then finally when you have calculated only you have to multiply by 10 and get the 251. Initially now here we have to take this 0.2 10 to the minus 3. So 0.2 10 to the minus 3 multiplied by half. That's going to be 0.1 10 to the minus 3 moles. So now you have found the number of moles of I2 formed from formed from the reaction between copper 2 plus and I minus. Now we had to write number of moles of I2 formed from reaction between Fe3 plus. Right? Reaction between Fe3 plus and I minus. Right. Calculate right? So it's going to be how much? The total amount. We calculate the total I2 Nisella. Where is it? The total I2, total I2, total I2. Then number of moles of I2. 0.4 10 to the minus 3. Right? 0.4 10 to the minus 3. So 0.4 minus 0.1 into 10 to the minus 3. That's going to be 0.3 10 to the minus 3. Right. Now we know the amount of I2. Now we look at this reaction. Here. This Fe3 plus I minus reaction. Make the habal now. Now you can see the I2 to Fe3 plus amount. I2 to Fe3 plus amount. Fe3 plus amount is 1:2. Stoichiometry 1:2. So number of moles of Fe3 plus in 25 cubic centimeters of S. Hari. You have to multiply by 10 multiply by 2. 2 the half the 2 ne 2, right? Where is it? Yeah, multiply by 2. 2 into number of moles of I2. Right? 2 into number of moles of I2. So 2 into number of moles of I2 will be how much? 0.3 10 to the power minus 3. 0.3 10 to the power minus 3. Now the answer will be 0.6 10 to the power minus 6. Sorry, 0.6 10 to the power minus 3. Now we can find number of moles of Fe3 plus in 250 cubic centimeters of S. So that's going to be 10 times, ne? 10 to the power minus 3. So 6 10 to the power minus 3 moles. Now you just calculate the mass. Mass of Fe. Mass of Fe will be 6 10 to the power minus 3 moles multiplied by 56 grams per mole. 56 grams per mole. Then per mole and mole cancel off. 56 into 6. 56 into 6. Calculate that. 56 into 6 is 0.336 grams. So as a mass percentage, 0.336 grams divided by 1 gram multiplied by 100, 33.6%. All done. So we have calculated the mass percentage of each. Sulfur, Fe and copper. Fe is 33.6% and copper is 12.7% and then sulfur is 25.6%. That's it. That's it. You will get your full marks for the calculation part if you do it like this. Okay? Did you understand? People, drop me a message. Did you understand? Okay? Hari people. Now, you go to the past papers. Now, I'm going to end the session now. You can do the past papers right now, right after this class. Try 2016, 2023, 2022, and 2017. Do these 4 past paper years. Do these 4 past paper years. Check the marking and analyze your mistakes. Like do it according to like මේ විදියට කරන්න. හරිද? කියන්නේ මේ order එකට ලස්සන්ට කරන්න question එක. හරිද? මෙහෙම diagram එක ඇඳලා reactions ලියලා by understanding the procedure මම දැන් කරා වගේ step by step do it accordingly. Okay? This is the method, right? This is the way how you should do a calculation question. So try those 4 past paper years now. Thank you for joining, people. I hope you learned something new in this critical time period. Please don't waste a single second. Please use every second to your benefit and then study hard, because this is going to be the last war. You're preparing for the last war. If you failed in this war, you will have to fight again. So please finish it this time. And fighting again is not easy. Looking at your friends just leave you and go for university, and you're just here doing it again, it will be hard, because I have been through that. So please finish it this year, this time itself. Please, like, when you try to take your phone in hand and like waste time, just ask yourself, okay, there's only 1 month left. Why am I even doing this? I can like watch YouTube, I can watch Instagram, I can watch Facebook after the exam as much as I want, because no one cares about that, right? No one cares about you. Just people, as soon as I came out from home from the exam, I just took my phone in the bed. I didn't even wake up until 9. I was just in my bed doing nothing. I was doing nothing, people. Nothing I did until 9. Right? I came home from 3. At 3 until 9, I didn't do anything. After the exam, you can do anything you want. No one will tell anything. So until that, now, like, tame your tiger inside. You have to tame your tiger inside, and you have to make yourself focus and do this stuff. You have to do this stuff. Otherwise, you will have to do it again. So, yeah, that's it, people. So, I'm going to end this session. Thank you for joining.